In this problem, we want to find the horizontal asymptote of a given rational function. In this problem, we're asked to find the horizontal asymptote for the function h of x equals 2x plus 1 over x plus 1. One way we can do this is to divide everything in the rational function by the highest power of x found in the denominator, which happens to be x. We get the following expression. I'm just rewriting h of x, in other words. We now have 2x over x plus 1 over x over x plus 1 over x. Simplifying this down, I get 2, because x over x is just 1, plus 1 over x, again, is just 1, plus 1 over x. Now what we're going to pretend is that x gets as large as we would like. So as x gets closer and closer and closer to infinity or minus infinity, we see that this term here, 1 over x, gets smaller and smaller and smaller. In other words, we can think of it as going to 0. Same thing occurs in the denominator. So what we're going to notice is that as x approaches positive or negative of infinity, we note that 1 over x must approach 0. Okay? So what we're going to do with that information is that in the long run, as x approaches positive or negative infinity, we note that 1 over x approaches 0, giving us a ratio of 2 over 1. Therefore, we know our horizontal asymptote to be the following: y equals 2 over 1, or just 2. Another way you can think about this as well is to look at the degrees in the numerator and denominator. One way in this problem, we see that the degree of the numerator is 1, the degree of the denominator is also 1. Therefore, we can take the ratio of the leading coefficients, 2 over 1, and we still get the horizontal asymptote 2. So our horizontal asymptote, again, is y equals 2, the horizontal line. In this problem, we found the horizontal asymptote for a given rational function.